Hello class 10. Let's solve exercise 6.5 from your Ncert book. Before we start the exercise, let us go through this theorem which will help us to solve it. If a perpendicular is drawn from the vertex containing the right angle of a right triangle to the hypotenuse, then the triangle on each side of the perpendicular are similar to each other and to the original triangle. If we take a triangle ABC right over here, and at angle C it is right angled, and opposite to it we have the hypotenuse AB. Now from point C, if we drop a perpendicular on the hypotenuse AB, then we are creating two more triangles on both sides. According to this theorem, these two triangles will be similar to each other. Not only that, each of these triangles are also similar to the entire or the original triangle ABC. So as a result, we can say ADC is similar to triangle ABC. Then triangle BCD is similar to triangle ABC. And again, triangle ADC is similar to triangle BCD. So these two triangles are similar to each other. This triangle is similar to the entire triangle. This triangle is again similar to the entire triangle. Even though the proof is not in your syllabus, let us see one part of it so that it becomes much more clearer. In triangle BDC and ABC, the BDC one is colored in blue and ABC is the entire triangle. We can see that angle C is common. So we can consider this as an equal angle or the common angle. Again, at point D, we can see in the blue triangle we have 90 degree, and for the entire triangle ABC at angle B we have 90 degree angle. So we can see that two angles are equal for the two triangles. One set is 90 degree, another set has common angle. So by AA similarity criterion, we can say these two triangles are similar. Similarly, we can also prove that triangle ABD is similar to triangle ABC, and then these two are also similar to each other. Using the previous theorem, now let us prove the Pythagoras theorem. So the Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So let us look at this triangle ABC. So at first we will see that at angle B we have the 90 degree angle. Now we need to prove that AC square is equals to AB square plus BC square, which is the Pythagoras theorem. The square of the hypotenuse AC square is equal to the sum of the remaining two sides. So that will be equal to AB square plus BC square. This is quite known to us, but to prove it using similarity, let us draw a perpendicular BD on AC. So this is a perpendicular, we have BD perpendicular on AC. Therefore angle D here is 90 degree. So we can see that we have created two more triangles. Using the theorem we have learned before, we can say that these two triangles are similar to each other. So we can say triangle ADB is similar to triangle ABC. So from this we can say that AD by AB is equals to AB by AC. Now let us cross multiply it. If we cross multiply, we can see that AC into AD is equals to AB into AB, that is equals to AB square. Mark it as 1. Again, let us take the other triangle BDC. So we know that BDC is also similar to the entire triangle ABC. From this we can get the ratio CD by BC is equals to BC by AC using the name of the triangles. Again, let us cross multiply. If we do that, we can get CD into AC is equals to BC squared. Mark it as 2. Now add equation 1 and 2. So we will add the left hand side of each equation. So we'll get AD into AC plus CD into AC is equals to AB square plus BC square. On the left hand side we can see that AC is common in both the terms. Let us take it common. If we take AC common, we will get AD plus CD into AC is equals to AB square plus BC square. In the diagram, AD plus CD is equal to AC. So we can rewrite this as AC. So AC into AC is equals to AC square. So AC square is equals to AB square plus BC square. Hence we can prove using similarity the Pythagoras theorem. This is in the syllabus. It can come in the examination. Let's start the exercise. Question number 1 says the sides of triangles are given below. Determine which of them are right angles. In case of a right triangle, write the length of this hypotenuse. For question number 1, 3 sides are given: 7 cm, 24 cm and 25 cm. We will simply use the Pythagoras theorem to prove whether they are the sides of a right angle triangle or not. So first, let us take out the square of each of these sides. So 7 square plus 24 square is equals to 49 plus 576, that is equals to 625. And 625 is the square of 25. So ultimately we can say that the length of the side would be 25. So what we can see here is sum of the square of two sides is equal to the square of the third side, which is the Pythagoras theorem. Now, in case of a right angle triangle, the longest side is the hypotenuse. Since in this tree 25 is the longest side and it satisfies this equation, therefore we can say the hypotenuse is 25 cm. In the second example, we have 3, 8 and 6 cm. So we can see that 3 and 6 are the smaller sides and 8 is the larger side. So what we have to do is take the square of 3 and 6 and add them and check whether that is the square of 8 or not. So 8 square equals to 64 and 3 square plus 6 square is equals to 45, which is not is equal to 64. Since the left hand side is not equal to the right hand side, therefore we can say these three are not the sides of a right angle triangle. Next we have 50 cm, 80 cm and 100 cm. As before, since 100 is the longest length or side here, therefore this will be considered as the hypotenuse if it belongs to a right angle triangle. So 100 square is equals to 10,000, and let us take the sum of the smaller squares. So 80 square plus 50 square is coming out to be 8900, which is not equal to 10,000. Hence we can say these are not the sides of a right angled triangle. In the next question we have the sides 13, 12 and 5 cm. So again we will go for the smaller sides. So 13 square equals to 169, and let us take the sum of the squares of the smaller sides. So 12 square plus 5 square is equal to 169, which is the square value of 13. So therefore we can see that we are having 12 square plus 5 square is equals to 13 square, and this satisfies the Pythagoras theorem. Hence we can say 5, 12 and 13 centimeter are the sides of a right angle triangle. Now since 13 is the longest length, therefore 13 is the length of the hypotenuse. Question number 2. PQR is a triangle right angled at P and M is a point on QR such that PM is perpendicular to QR. Show that PM square is equals to QM into MR. Let us draw a triangle on the right hand side where PRQ is the triangle, or PQR is the triangle where angle P is 90 degree. Now P is a point on QR, M is a point on QR such that PM is perpendicular to QR. So at M also we have 90 degree angle. We have to show that PM square is equals to QM into MR. That is PM and QM and PM and MR. That means we can take the triangles PMR and the triangle PMQ. So from the question itself, it is very clear to us which two triangles we have to prove similar as. So if we can prove them to be similar, then we will obviously get the proportional sides, and then from there we can cross multiply and get this relation. So let us first consider this angle to be x. Let NPR is equal to x. This angle is x and this angle is already 90 degree. Now in this triangle PRM, we can say that this angle R, or rather angle MRP, will be equal to 180 minus 90 minus x, right? Using the angle sum property, 180 minus 90 minus x will be the value of this angle. So this is the one which is coming out to be 90 minus x. Similarly, in triangle MPR, we can say that angle MPQ is equal to, so MPQ is this particular angle. Now we know that angle P is 90 degree. If angle P is 90 and this angle is x, obviously angle MPQ is 90 minus x. So from here we can also say that this is 90 degree, this is 90 minus x. So we can find out this angle using angle sum property. So angle MQP will be equals to 180 minus 90 minus 90 minus x. So ultimately we'll get the value as x. So this angle is also x. This is x, this is x. This is 90 minus x, this is also 90 minus x. And these two angles are 90. So we can see this is 90, this is x, this is also x, and these two angles are 90. This one is 90, this one is 90. So we have already got two angles which are equal. So by AAA similarity criterion, or we can say by AA similarity criterion, triangle QMP is similar to triangle PMR. So we know the corresponding sides of the triangles are proportional. From there we can write QM by PM is equal to MP by MR. So we'll write down this relation of proportional sides, and now just multiply, cross multiply, we'll get PM square is equals to QM into MR. Hence proved. In the given figure, ABD is a triangle right angled at A and AC is perpendicular to BD. Show that AB square equals to BC into BD. So in this figure, we can see that ABD is a right angle triangle and it is right angled at A. Now AC is a perpendicular on BD. That makes angle C 90 degree. We have to show that AB square is equals to BC into AD. So we can choose the triangle from here itself. So we have AB, BC and AD. So AB and BC belongs to triangle ABC, and AB and BD belongs to triangle ABD. So we'll work with triangle ABC and ABD. In triangle ABC, angle BAD is equal to 90 degree, this angle, and these are perpendicular. So since it is a perpendicular on a right angle triangle, therefore we can simply say that these two triangles, that is BAC, this one, and BDA, that is the larger triangle, are similar using the theorem. So from here we can write down the ratio as they are similar of the sides, that is BA by BD is equals to BC by BA. Now cross multiply, we can get AB square is equals to BC into BD, hence proved. In the second part, it has asked to prove that AC square equals to BC into DC. Again, let us choose the triangle. Here, AC, BC and DC are the sides. So we have AC, BC and DC. So we have AC twice, so AC and BC, which means this triangle, and AC and CD, that means this triangle. So we will deal with triangle BAC and triangle ADC. These two triangles are also similar to each other by theorem. Therefore, we will use the theorem and write down that triangle BAC is similar to triangle ADC. Now let's write down the proportional sides. So AC by DC is equals to BC by AC. Now let's cross multiply. So AC square is equals to BC into DC. The third one asks us to prove AD square equals to BD into CD. So the sides associated here are AD, BD and CD. AD appears twice. So AD, BD and CD. So we'll have AD and BD, that is triangle ABD, and AD and CD, that is triangle ACD. So triangle ABD and ACD. So let's take these two, and we already know that these are also similar by the theorem. Therefore, let's write down that they are similar, and let's write down the ratio of the sides. So we can write AD by BC is equals to BD by AD. Let's cross multiply. So AD square is equals to BD by AD. In the next question, triangle ABC is an isosceles triangle right angled at C. Prove that AB square is equals to twice of AC square. In the given figure, we can see that ABC is a right angle triangle where two sides are equal. So it is right angled at C. Okay, so we can say that AC and BC are equal because AB is clearly the hypotenuse which is opposite to the right angle. So AC will be equal to BC. So let us write it down in triangle ABC. Angle ACB is 90, angle AC equals to BC. Now since angle ABC is a right angle triangle, we can write down AB square is equals to AC square plus BC square by Pythagoras theorem. Now instead of BC, we can write down AC by this equation. So instead of BC, we are writing down AC. So we have the equation AB square equals to AC square plus AC square. Ultimately, we can write down AB square equals to twice of AC square. Hence, proved. ABC is an isosceles triangle with AC is equals to BC. If AB square is equals to twice of AC square, prove that triangle ABC is a right angled triangle. So in this triangle, we have a triangle which is isosceles in nature. So here it is given AC is equals to BC. We have to prove AB square is equals to twice of AC square. It is actually given and we have to prove that it is a right angle triangle. This question is the exact opposite to the previous one. So let us write down whatever information we have. We have in triangle ABC, AC is equals to BC and AB square is equals to twice of AC square. Now, since AB square equals to twice of AC square, we can break twice of AC into AC square plus AC square. Now we'll take any one of these AC squares and substitute it by the term BC. Okay, since AC is equals to BC, which is already given. So AB square is equals to AC square plus BC square. We are just transforming one of them. Now since AB square is equals to AC square plus BC square, which is ultimately the Pythagoras theorem, so therefore by converse of Pythagoras theorem we can write down that angle ACB right over here, that is angle C, is 90 degree. Hence triangle ABC is a right. Question number 6. ABC is an equilateral triangle of side 2A. Find each of its altitudes. By altitudes we mean height. An equilateral triangle means a triangle having three of its sides equal. All three sides are of equal length. Here it is given as 2A. That means all three sides of the triangle ABC here is A. To take out the length of the altitudes, let us drop a perpendicular. Now, for a equilateral triangle, the perpendicular and the bisector is the same. That is, it is a perpendicular bisector. So, since AD is a perpendicular, it is also a bisector. Therefore, side BC is divided into equal half. That is, if the length of BC is 2A, then CD is equals to BD is equal to A, because D is the midpoint of BC. Okay, so now in triangle ABD, we can say in triangle ABD, you can use the Pythagoras theorem, that is AC square is equals to, in ABD, AB square is equals to AD square plus BD square. So we can say AD square is equals to AB square minus BD square. Let's put the values of AB is equals to 2A. So AB square equals to 2A square. BD square is equals to A square. From here, if we just calculate, we'll get AD square equals to 3A square. So ultimately AD is equals to root over of 3A. Since all the sides of the equilateral triangle are equal, therefore their altitudes are also equal, and all of their length will be root 3A units. Question number 7. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonal. So here we can see we have a rhombus. So in the rhombus ABCD, we have the diagonals AC and BD. And by property, we know that the diagonals of a rhombus bisect each other at right angles. That means the angles at O for all of them will be 90 degree, and also the diagonals are getting bisected at the point of intersection O. That means OA is equals to OC, that is equals to OD, that is also equal to OD. Okay, that is OA equals to OC, OB equals to OD, and angle O for all these cases is 90 degree. According to the question, we have to prove that the sum of the square of the sides, so these are the sides AB, BC, CD and DA, the sum of its squares, that is AB square plus BC square plus CD square plus DA square, is equal to sum of the square of its diagonals. So the diagonals are AC and BD, so AC square plus BD square. This is what we have to prove. Now since each of these triangles are right angle triangles, we can easily apply the Pythagoras theorem. So in triangle OAB, we can write down AB square is equals to OA square plus OB square. Because angle O is 90 degree, that means opposite to the 90 degree is the hypotenuse. So AB square equals to OA square plus OB square by Pythagoras theorem. Now AC square, AC is equal to OA plus OB, because at O it is bisected. So we can say that AC is equal to twice of OA, or OA is equals to half of AC, right? So instead of OA, we'll write down half of AC whole square, plus again instead of OB, we'll similarly write down half of BD whole square. So if we simplify, we'll get AB square is equals to 1 by 4 AC square plus 1 by 4 BD square. If we just cross multiply, we'll get 4B square equals to AC square plus BD square. Now we have 4AB square. Let's break it individually. AB square plus AB square plus AB square plus AB square is equals to AC square plus BD square. So we have broken it 4 times. Now we know the sum of all the sides, or rather all the sides are of equal length, because all the sides of a rhombus are equal. So instead of AB, we can write down BC. Instead of AB again, we can write down CD. And instead of AB here, we can write down DA. So these are the name of each of the sides, and all the sum of their squares is equal to the right hand side. Hence, proved. In this question, in the given figure, O is a point in the interior of a triangle ABC. So we have a triangle ABC and O is an interior point. OD is a perpendicular on BC, OE is a perpendicular on AC, OF is a perpendicular on AB. Show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equals to AF square plus BD square plus CE square. Before we do all these things, let us first join OA, OB and OC. So join OB, OC, and we will get this diagram after joining them. So we can see that the whole triangle has been broken into numerous triangles. It will be 1, 2, 3, 4 and 5, 6. 6 of triangles. We have 6 triangles and all of them are right angled. If you check these two, this is the right angle right over here. For this triangle, this is the right angle. For this triangle, this is the right angle E. For this triangle, D is the right angle. Here also D is the right angle. Here F is the right angle. So this triangle has been broken into 6 right angles. So to prove the first one, in right triangle AFO, this one we can write down. So if angle F is the 90 degree, opposite to it is the hypotenuse. So we can say OA square is equals to OF square plus AF square, right? So OA square is equals to AF square plus OF square. Similarly, we can take triangle BDO. So in triangle BDO, we can write down OB square is equals to BD square plus OD square, because D is 90 degree right here. And in triangle CEO, we are taking OC square is equals to OE square plus CE square. So mark them as 1, 2 and 3. Let's add them. If we add these 3 equations, on the left hand side we are getting OA square, OB square plus OC square, and on the right hand side the sum of all of these. So AF square plus OF square plus BD square plus OD square plus CE square plus OE square. Now let us take OS square, OD square and OE square to the left hand side. If we do so, then we can get this particular equation, which is the one they have asked for. Hence proved. For the second part, in this result, we have got AF square plus BD square plus CE square. We have to prove that AF square plus BD square plus CE square is equals to AE square plus CD square plus BF square. So, using the previous result, we can write down the whole equation right over here. Now, we just have to regroup it. See, if we take OA square minus OE square. Why? Because we need AE. Now, if we look into this triangle where we have AE, so we can see that OA square is equals to AE square plus OE square. So we can write down AE square is equals to OA square minus OE square. So if we can bring OA square minus OE square, then this together will become AE square by Pythagoras theorem. You can write it down separately for understanding better, or you can write directly. There won't be any problem. So we will rearrange few of the terms. Since we have BF square, so we'll take OB and OEF together. Again, since we have CD square, we'll take OC square and OD square together in a bracket. So from here, we can write down using Pythagoras theorem these particular values. Therefore, we'll get AE square plus BF square plus CD square as the result. So hence, proof. Thank you everyone for watching the video. Hope it was helpful for everyone. Bye bye.